Today we're going to have an electrifying experience. We're going to be looking at the electrolysis of water. Now before we get started with this, I know we all want to just get going with our experiment. We want to do a little bit of background information so that we can better understand what's happening. First of all, we look at the word electrolysis. Electro means electricity. We're going to be using electricity. No, we're not taking it from the wall socket. Instead, we're going to be using a 9-volt battery. Not enough current there to cause you any damage. Important. Second of all, we have this portion of the word called lysis. That means to break something down. And so the electrolysis of water means it is the breakdown of a substance by electricity. In this case, that substance is a compound known as water. So if we look at the purpose statement, it is to indirectly observe electrical conductivity by breaking down water molecules into two different products, oxygen gas and hydrogen gas. The hypothesis will be as follows. Water will be broken down into its elements when electricity is passed through the water. We're going to be looking at whether or not compounds are ionic or they're covalent. If they're ionic, they will conduct electricity. If they're covalent, they will not. So with all of that said, that is what we want to get started with. We're going to be looking at how in the world can we tell whether or not a substance is ionic versus covalent simply by the passage of electricity. So if we're going to do that, what are we looking for? If I take this battery and it's connected to these wires, which just happens to be pre-done, just like that, we look at this, how is this going to tell me anything about our substances here? Well, what we're going to be looking for is breaking down water. What do we say water is? Water is a compound, H2O. And if we look at what kind of a compound is it, we find the hydrogen is on the left side, we find that the oxygen is on the right side. But remember, hydrogen is the exception to the rule. And since that is the case, we know that both hydrogen and oxygen are nonmetals. So we look at water, and water is a covalent substance. Being covalent, what does that tell us? It shouldn't conduct electricity. So if it does conduct electricity, what should we find out? Well, first of all, there's a reaction I want you to be aware of. This is called a decomposition reaction. We have AB yields A plus B. AB is the compound, and it's going to break down into the simpler forms of elements, A and element B. Let's get a little bit more specific. We have AB is the water, the compound. It's going to be broken down into its elements, oxygen gas and hydrogen gas. We're going to use electricity to do this. Most decomposition reactions will require some electricity, some energy, to actually cause this to happen. So let's walk through the procedure just briefly so we better understand what we need to do. We take whatever glass container we're going to be using. I have up there the 100 ml beaker. You can use distilled water, can use just your tap water, that's all fine. Okay, rinse it out several times just to make sure, especially if it's going to be like a beaker from before, that you don't have anything that would contaminate and mess up our results here. Now we're going to take about 80 mLs of water and put it into our container. That number is not written in stone. You can put whatever amount of water you want to. You'll notice I have a lot more than 80 mLs in these containers right here, but it's going to hopefully be more visually pleasant as we start looking at these things. We take our two wires, we strip the insulation off, have about 2 centimeters bare from each side. So on this side we had our copper wire, this side we have copper wire. So they did it on both of them, and we're connecting it to our battery terminal as is. Notice with your battery that the big portion of it, the big terminal, is going to be the negative, and the small terminal is going to be positive. With that said, let's keep going on here. We're attaching one wire's end to one post and the other wire's end to the other, as mentioned. We put our tape associated with it. We're going to immerse the other ends of the wire into the water, and then we're going to see what's happening. So here's our very first one. Seeing that we're doing a lab, we want to be careful. So pull out your safety glasses, and let's see whether or not we can see anything happen. So here's our battery. Make sure it's a living battery, because if it's dead, then everything here is going to show a lack of conduction. Remember, the way we're going to be able to tell conduction is taking place is breaking down this water. What's it breaking down to? It is breaking down to hydrogen gas and oxygen gas. When you see that, you're going to see bubbles forming right on the wires. So we'll go ahead and we're going to set this thing down, and we're going to stare at it, and stare at it, and stare at it. Now, as I'm looking at this thing, I am seeing no indication whatsoever that decomposition is actually taking place. If it were, I would be seeing bubbles emitting from the ends of these wires. Well, should that surprise me? What did we say the formula was for water? H2O. Both of those are nonmetals. They would make a covalent substance. So I look at that and say, there's not much happening here. You might see just a little bit. Now, actually, now as I look at this a little bit, I see coming off the black wire a little tiny bit of bubbling there. But that could also be because of contamination in this container. So with that said, I look at that, I write down what I'm seeing here, and I say, you know what? I don't think water is a good conductor of electricity. We went ahead and did it. Now we're going to go to our next glass. We're going to go ahead and we're going to take some baking soda. So I'm going to take about half of a teaspoon, like that. We're going to set it in there, just like that. Set that down so it's kind of out of our way. Going to stir it. And you try to get it as dissolved as you possibly can. Now you look at the periodic table. You have a sodium. Where's that found? That's on the left side. We find hydrogen. That's on the left side. We find carbon. That's on the right side. We find oxygen. That's on the right side. Just like magic, you'd never know I put anything in there. Look at that. It's all gone. All right. Now we have a mixture. We could pretend that the water itself was something that was pure. Probably not. Got some contaminants. We know baking soda is a pure substance. It's a compound. But now we put the two together, we get a mixture. So now we go ahead and take these same wires. I don't have to really rinse them off or do anything. Why? Because I had it just in water beforehand. So I'll set it in here. And now we begin to see bubbles. Look at that. Now that's pretty cool. In fact, look at it swirling still after I went ahead and I did my bit of stirring on this thing. You can definitely see something going on here. Wow, okay, I am seeing bubbles. Bubbles is one of the indicators of a chemical reaction. Do you know what the other indicators are? And remember, bubbles mean what? Gases are released. That's what's going on here. Well, we think of this and say, well, what else are we going to see here? Well, as time goes on, and we'll probably come back to this one just to kind of look at it a little bit more, we should expect to be seeing a color change. And if you keep this in here long enough, you're going to see a change in the color. We go from transparent water, it should be colorless, tasteless, it should be odorless, that's good water. Now we're going to start seeing some colors developing. That can be an indicator associated with a chemical reaction. Keep in mind, just because you see a color change doesn't mean it is a chemical reaction. You could put food coloring into water, and that would certainly change its color, but guess what? All we're really doing is dissolving one thing to the other, the food coloring into water in that case, and that's a physical change, not a chemical change. So when we're talking about color change, it doesn't necessitate or demand that it's a chemical reaction, but it could be. Could be one of those indicators. Now that we have a color change starting to happen here, as well as bubbles, now we have two things on the side of chemistry really taking place here. Now, we keep that in mind and we say, okay, something is happening. Write down your observations as this is taking place. What else might be going on here that would indicate a chemical change? Well, if we really are having a circuit that is now a closed circuit, now where electrons are flowing from the negative terminal to the positive, we may actually generate some heat in the battery. So feel your battery. Do you feel heat flow? That's a third indicator associated with a chemical reaction. So we have bubbles, we have color change, we have heat flow. The chemical reaction could get warmer, could get colder. There's typically some flow of energy associated with a chemical reaction. The fourth one we'll talk more about down the road is called a precipitate. That's where if you take like one liquid, you add another liquid to it, you see a solid precipitate out. Precipitate, think of kind of like the rain is a precipitation, something coming out of the air, coming out of a fluid medium and coming down. If all of a sudden we start noticing down here that, oh my goodness, you know, there's a bunch of stuff accumulating in the bottom, that would be your fourth indicator of a chemical reaction. So you look at this and say, you know what? I am seeing some changes taking place here. This is pretty cool. The baking soda definitely is allowing conduction of electricity, and hence, it goes along with my hypothesis that baking soda is an ionic compound based on the position of the individual atoms found within that molecule. All right, good enough. We just saw that. Now what we're going to do is we're going to rinse out our beaker Now you'll have to do that because again, you've got only one beaker to work with. I'm going to simply just take this out shortly, put it in here, and just kind of clean off the wires. Now, I'm cheating a little bit, you know, but again, we're trying to videotape this and facilitate this so it's quick and easy versus where we're making a lot of mess and taking time up doing it. Now what we're going to do is we're going to take our next substance. We just went ahead and did our baking soda. Let's go ahead and do our sugar. Okay, so I use a different little scoop here so I'm not changing things up too much. Put our sugar in here. Put it in. More of a powdered sugar kind of a look. Going to stir it around. And we look at the chemical formula associated with this. All right, what do we expect to see happen here? Is this covalent? Is it ionic? If it's ionic, it should conduct electricity. If it's not ionic, it's covalent, it should not. So what do you think based on the chemical formula? If you want to, pause, think about it. Take a look at the various atoms on the periodic table. See if you can figure it out. See if we can get all this stuff out of here. Okay, obviously it looks like a different substance, just comparing the two that we have next to each other. I should mention one other thing before we go any further here. This one, which was water, had no experimental variable in it. It was simply water. We're testing everything against water. We'd say this is the control. So we have the control that we're basing to see, okay, this is showing no indication that conduction of electricity is taking place. It's covalent. Now let's see whether or not we see anything happening here. We're going to set it in, and we're going to look for bubbles. So we'll put it up against the side. I'm just not seeing anything. Wow, that's exactly what I would have predicted. I didn't even have to pull out my battery, didn't have to do the wires, didn't have to do anything. I could have just told you that. But it's always fun to do the experimental side of science also, just to make sure our predictions are accurate. So we look at this and we have water is covalent, no electricity. Sugar is covalent, no electricity is conducted. Baking soda is ionic, we saw bubbles. All right, so we look at that and say, okay, nothing much happening there. We're going to do one more. I'm just going to throw this one in. It's actually not in your lab at all. But what we want to do is we want to take one more substance. I decided to try something known as just detergent. You know, the kind that you're washing your clothes with. And we're going to put that in here. And what we want to see is whether or not this substance here, I don't have a chemical formula at all to look at to be able to predict anything, but I want to see whether or not I see some kind of a change take place. So we'll take this spoon this time, go around and around and around, make some nice little swirls. Not dissolving real good, but that's okay. We know it dissolves when it's in the washing machine. All right, we'll say that's good. Now, with all that said, what do you guys think? Do you think it's going to have the ability to conduct electricity? If it does, we see bubbles. Or isn't it? Well, there's only one way to try. So let's go ahead and we're going to take our wire again from both ends and we're going to set it in here and see what happens. Oh my goodness. I am seeing lots and lots of bubbles coming off of this thing. Lots and lots and lots. So it's apparent that this actually is ionic also. And many times they talk about detergents having its two-sided molecule. One side is actually covalent on one side is ionic on the other side, believe that or not. And so the side that's ionic is the side where I'm seeing bubbles actually forming from this thing. Very, very interesting. So here's a molecule that actually has both sides to it. Pretty crazy. And the reason why that actually works is the ionic side is going to be the side that can dissolve in water real easy. You don't have any problems. The covalent, we'll talk more about this down the road, is going to be the side that helps to break down some of those tough stains like your blood and your grass and some of those things that we have on our clothing and we want to get rid of. So isn't that interesting? We have covalent, ionic, covalent, ionic. Now there's one other thing I haven't talked about that is kind of interesting, and I'm going to pull it out of here. Let's go ahead and rinse it off just a little bit. So again, we get that stuff off of here. But I'm going to go back to our second glass. That was the one that had the baking soda in it. We put it back in there, and you should immediately see bubbles. It is ionic. If you look at this thing right here, you're going to notice something happening to the wires. I'm going to try to hold it up close where you can actually see it. Positive terminal is going to be the little small knob associated that's coming up from the 9-volt battery. And if you look at this wire coming off of it, you're going to notice that the wire at the very end is blue in color. It has changed color. If we look over here on this side, this is the negative side. So this is the bigger knob that you have associated with it. If you look at that, you'll see that it actually is getting a little bit darker. If you do this long enough, you'll see the darker part coming off here. And the question is, what's really happening here? Well, I'm glad you asked that question. It turns out that the side here that's coming off of the positive terminal actually is releasing oxygen gas. So we have oxygen coming off of there. How do we know that? Well, think about copper. Copper is this element that makes up this wire. When copper mixes with oxygen, what color does it turn? Think of the Statue of Liberty. It turns blue. Oh my goodness, look at that. Blue is coming off of there. The oxygen is coming off right there. If you look at the chemical equation on page number 1, we see that water in a liquid form breaks down into one molecule of oxygen. If we're starting with the initial amount of water, okay, the 2 water molecules. If we look over here on the other side of the battery, this is the side where the hydrogen's coming off. And typically what happens is the copper itself is going to turn a darker color. Even that discolors a little bit. And if you look at the chemical formula or the equation that you see on page 1, you see there's actually twice as much hydrogen is produced from the this terminal than the oxygen that we have produced over there. And we can also start seeing color changes. Things are really starting to go really well now. It's really kind of fun. So all of a sudden, we're really seeing this works. Here we see indication indirectly that we are breaking down water. We're seeing the evidence of bubbles. We're seeing the change to this copper element. And voila, we see chemistry in action. How much fun is that? Have a ball, play around with this. This is something that, again, you can learn a lot from it. Make sure you understand the chemical equation that's on your sheet, what's happening. Twice as much hydrogen was predicted by the equation compared to the amount of oxygen. 2-to-1 relationship. You should see a lot more bubbles coming off on that negative terminal. With that said, you guys have fun, and we will see you again next time with more Fun with Science with Dr. Dan.